All right. Thank you everybody for coming. My name's Grace. I am with Women Who Code Denver Boulder chapter, and I'm a director along with a few others. I think Dom and Jen are both on the call, and then we have two more, Rafna and Jordan. Always open to answer questions, so feel free to ping us if you ever have questions about Women Who Code Denver Boulder or our global chapter as well. Tonight's event is from 6 to approximately 7:30 Mountain Time. We have folks from all over, so just want to clarify the time zone. We'll start now with introductions and then jump right into the lightning talks. And those will be about 10 minutes with about 5 minutes Q&A. We'll try to move things along to make sure that there's enough time for all of them. We also created a channel in our Denver Boulder Slack group for continued conversation and networking if you're interested. If you're not already in that group, just reach out to denver@womenwhocode.com or to me, Dom, or Jen, and we can help you get added to that Slack community so you can participate in that conversation as well as our other channels. And then just a quick shout out to the online event best practices that we've probably all heard for a year now, but make sure to mute yourself when you're not talking. And then always prefer to have your video on if you're comfortable so we can see each other's faces. So Women Who Code Boulder Denver is part of a global organization called Women Who Code. And the mission is to inspire women to excel in technology careers. The vision of the group is a world where women are representative as technical execs, founders, VCs, board members, and software engineers. This is our vision, but we join everybody to be a part of executing that vision. So all are welcome to our events. And for Women Who Code Boulder Denver, we do that through our Slack community, events like this one that are technical focused, events that are more career focused, and more. And then there's also global tracks, which a lot of our speakers tonight are from the Women Who Code mobile track. So if there's any questions about how to get involved with any of that, please let me know. And with that said, I just wanted to speak quickly to the code of conduct. This is an inclusive community. We want to invite and welcome everyone to our events, but it's also a harassment-free zone. So we'll make sure that this event remains safe and enjoyable. If there's anything that's happening that makes you feel unsafe, please reach out, but I don't foresee any issues. So with that said, I'll hand it over and we can get started.
Sorry about that, I was on mute. Hi everybody, my name is Jovanka Balach. I'm a program manager here at our local Uber engineering office in Boulder. I apologize for the squeaky toys you might be hearing from my dogs in the background. You know, just everyone's kind of pretty familiar with Uber in general. We have a pretty robust engineering office in Boulder, and we touch on a lot of different things. You know, in the slide, you'll see all of the different areas that Uber is a part of. So regardless if you're interested in, you know, transit or logistics or health, there's, you know, a place for you at our company. With that being said, we have a decently sized and growing mobile development group that we are hiring for. Uber-wide, we've got over like 100 positions that we're hiring for. In the Boulder office, we've got a handful as well. So if you are interested in that, please go check out our career page. I'll be your moderator tonight. So as Grace mentioned, we're going to be doing about 10 minutes for each talk and then 5 minutes for Q&A. Grace just posted the link to the Slido where you can ask your questions to each of our presenters. And now we're just going to move on into our introductions and then our lightning talks. So let's go ahead and start our introductions just based on talk order. So Crystabelle, would you like to introduce yourself?
Hi, I was not aware that we're doing an introduction. Really quick, I'm a user experience engineer with over 10 years of experience building websites for internal teams and external clients.
Awesome, thank you. Next we have Rashi.
Yeah, hi everyone. I'm from India and I'm a React Native developer at Think Future Technologies, based at an Indian company. Happy to be here, thanks.
Perfect, we're happy to have you. And thanks for staying up late for us, or I guess waking up pretty early for us. Claudia, you are next.
Hi, my name is Claudia. I currently live in California, working as a freelancer, building mobile applications for small companies.
Awesome, thank you. Sierra?
I'm Sierra. I'm a mobile developer out of Cincinnati, Ohio. I primarily focus on native Android, and I currently work in the IoT space.
Thanks. Happy to have you here. And last but not least, Usha.
Hi, my name is Usha, and I'm an Android engineer at Uber. I'm from Bay Area.
Awesome, thank you. All right, so we're going to go ahead and start our talks. Crystabelle, the floor is yours.
Alrighty, can everyone see the screen?
Yep.
Cool. Thank you. Alrighty. So hi, I'm Crystabelle, and today I'm here to talk about getting unstuck, how I used a user flow diagram to build an initial version of my app. Today, you'll learn about what a user flow diagram is, how I made one, and how I used it to inform my decisions. Again, I'm a user experience engineer with a little over 10 years experience building websites for internal teams and external clients. I recently decided to expand my technical knowledge to include Android app development. And to that end, I decided to apply what I've learned so far by building a math game to help me practice solving math problems mentally. And my focus for this initial version of my app is to implement basic functionality. I thought this was a pretty straightforward plan, so I immediately started coding. Unfortunately, I quickly found myself stuck, just like this vehicle stuck in the mud. I wasn't sure what direction to take in terms of code structure, fragments, or whether I needed any special classes. I thought my primary problem was that I didn't know what code I needed to write. But the real problem was I hadn't clearly answered one question. What should users do in the app? And to figure that out, I turned to user flow diagrams, a tool I've used when previously building websites. So let's dive in to learn what user flow diagrams are and why they're helpful. A user flow diagram visually describes the order of specific tasks a user can see or do in an app, and they're always created from the user's perspective. Here's an example of a fictional timer app. So here, the user can start the app. If the user has created one or more timers, we'll have the user view timers. If not, we'll have them create a timer and then view their list of timers. And they have four options or four choices of tasks to do while they view their timers. They can add, toggle, edit, or delete timers. Now, as a developer, you can use a completed diagram like this to guide your app structure. And it helps in two ways. First, user flow diagrams can help you define wireframes and identify the UI elements that you'll use, the things that your user interacts with or sees. It also helps with defining and identifying code components, things such as app states, functions, constants, and variables. User flow diagrams also help you helps you boost productivity because they help you figure out what you can already build, narrows down where you're stuck, and by virtue of both of these, it creates a plan to help you get unstuck. And ultimately, user flow diagrams lead to happier users because they help you plan a clear task order, because a clear task order helps your users complete tasks seamlessly. In other words, they leave your app happy. Here's how I created my user flow diagram for my initial app, for the initial version of my app. First, I answered this question: what should users do in the app in general? And I decided that my users are going to start the game, they'll then play the game, and then they'll see stats when they finish the game. Here's the corresponding user flow diagram. So far, so good. It reflects everything I just stated. Now, I realized while looking at this initial user flow diagram that I didn't know how to implement the following already: create a title screen, initiate the game, and then show results on a game over screen. I also realized I wasn't sure how to implement the play game task. And so here's how I figured out how to implement that task. Again, I asked myself, what should users do when they play the game? And I decided that users are going to ultimately answer 3 problems. First thing they'll do is they'll see a problem along with possible answers, and then they'll choose an answer. Here's the corresponding diagram. And that again reflects everything I just said. And so I've accounted for the user viewing the problem, answering the choices, and then the next thing they do is choose an answer. And because I'm asking 3 questions per game, I've included a decision point to determine whether I need to show another question or end the game. So at this point, I figured out all the main things a user should do in my app. Now here's how I combined the diagrams. Here's the initial diagram I created earlier. It covers what the user generally does in the app. Now let's add the play game user flow diagram. You'll see that the play game user flow is inside the dashed rounded rectangle. And here's my completed diagram. I don't have any other tasks for the user to do in this version, so it's done. Now, here's how I used my completed user flow diagram to structure my app. First thing I decided to create was wireframes. Now let's look at the first part of my user flow diagram. The first things users can do are view the app start screen and tap the play game button. Here's the corresponding wireframe that I decided to create. I have a welcome message and a play game button. The next thing that my users can do in my app is play the game. And to play the game, they're viewing a problem and the corresponding answer choices, and they can choose an answer. Looking at this wireframe, I realized I need to provide a way for the user to view that problem and those possible answers. And I needed to assign an interactive UI element for those answers. I opted to create this wireframe. I used a text view box to show the equation, in this case 1 + 2. And I decided to use buttons to represent the 4 possible answers. So when a user taps the button, they'll provide an answer. The last thing a user can do is view game stats once the game ends. And here's a wireframe that does just that. I have effectively a game over message, and then I show the statistics in 1 sentence. You got the 2 out of 3 questions correct. And that's it for wireframes. Next thing I did is I took my completed flow diagram and those wireframes to determine my code components. The title and game over screens are pretty straightforward. Though the play game task is a little bit more complex. So let's walk through it. Here's the play game task again. I realized that the functionality is pretty self-contained, so I decided to have one class handle all the functionality, and I decided to call it play game. Now, along with classes, you need functions. And so my class is clearly defined, play game, so all my functions are going to correspond to that. The first thing my user does in the play game task is to view problem and answer the choices. And for us to help the user, we show a problem. Next thing the user does is choose an answer. And so at that point, we then get the user answer and we check the user answer. And then finally, we check to see if we can continue the game. And there we have it. There's play game and our functions. To make these functions work, we need to figure out our constants and variables. In my user flow diagram, I determined one possible constant for max problem count. Now remember, I decided to create my app so that I asked 3 problems to constitute a game. So I would assign it to max problem count. So in the future, I could change that max problem count to 5 or 10 or whatever. So there's my constant. I also have variables. In this particular step, I keep track of the problem answer and the number of problems asked so far. And in this step, I note the user's answer and I keep track of the number of problems answered correctly. And the last thing I need to account for are the UI elements. Now I realized, looking at my wireframe, I realized while I was constructing it that I actually had already determined my UI elements. And these UI elements are text area for the equation and the buttons for my answers. And I declare these UI elements in code, I update them, and I listen to them. So in this particular step, I update the text area, the equation, and the buttons, my answer. And then when the user chooses an answer, I have a listener attached to each of the buttons that detects which button the user pressed. And there we are. I have my wireframes, I have my code components, I'm now unstuck. And it's awesome because now I have a clear defined path. I have wireframes and I have code and I have a code architecture to help me build the initial version of my app. So let's go over this really quick. User flow diagrams identify what you understand. They also simplify the unknown into smaller manageable items. And they help structure your app in terms of wireframes and code components. They're also great for planning new apps and features because they help you think about how the user will use your app. Remember, if you think about your user's path to the app, that means you're thinking about how they'll accomplish their tasks, and it helps increase their chances of success. User flow diagrams are also quick to create and iterate upon, and UX and developers understand these. Finally, user flow diagrams reduce stumbling blocks, ultimately saving you time, because you'll know what you'll code or design before you do either. And they also help you see where errors could occur and allow you a chance to handle them appropriately. So with that, I encourage you to use user flow diagrams in your next project. Thank you.
Thank you so much, Crystabelle. We do have some questions that came in while you were speaking, so I'll go ahead and read those off. The first one from Claudia is, in your experience, what is the easiest or quickest way to create flow diagrams?
That's a good question. The quickest and easiest way is pencil and paper. It's nice to have these user flow diagram software, and it's a great skill to have and develop. But when you just need something and you just need to get it done, pencil and paper.
Awesome. Thank you for that answer. And then our second question from Dom is, do you have any favorite tools you like to use to create the flow diagrams?
Up until recently, that favorite tool was Balsamiq. And Balsamiq is software that I use primarily for wireframing. And for a while, I used it to create my user flow diagrams. I discovered that I couldn't attach the arrows easily between various user flow diagram elements. And so I decided to use Google Slides. In fact, for this talk, all the user flow diagrams in this particular talk were created on Google Slides. It's good for really small diagrams, but I wouldn't recommend it for long term. I'm actually looking for a solution, and two that I've found so far that I'm going to evaluate are Figma and Lucidchart. There are many more to look at too.
Awesome. Thank you for that. And thank you for your presentation. It was wonderful. We are going to move on to our next speaker, which is Rashi. Rashi, please go ahead.
Yeah, hi everyone. I'm sharing my screen. Is it visible, my presentation? Yep. Okay, so hi everyone. Today I'll be talking about React Native, and let me introduce myself first. So myself, Rashi Jain, and I work as a software engineer at Think Future Technologies, India. And I majorly work on React.js and React Native to create mobile and web applications. For today, the topic of discussion would be what is React Native? Prerequisites to run a React Native application on your system, like what are the requirements of the system that you need to have to run a React Native application on your system. I'll give you a brief demo of how to create like a running application of React Native in Android and iOS simulator. I'll talk about the pros and cons working with React Native. So let's start with the first, which is what is React Native. So React Native is an open platform to create mobile applications. My screen got stuck. It offers faster mobile development and most efficiently code sharing across various platforms like Android, iOS, and web. And in React Native, it's a kind of framework which is built upon a library called React.js, which we use to create the web application. In React Native, what happens is we create small components, and by building a tree-like structure from these small components, and to create this component, we use JavaScript code, which is called JSX, which is kind of an extensible JavaScript where we can write the JavaScript and the HTML code in the same file, and it will get compiled into the native code for Android and iOS. So the prerequisites which is required to have in the system, first one is the Android SDK, the Java simulator and setup in your system for Android Studio. So to run the application in Android, we must have to have an Android SDK and Java setup in my system, and to run and to check like how the application is looking in the phone. We need to have a simulator. For the simulator, we can use the Android Studio, or we can download it with the Genymotions for Android. We need to have Node.js. So basically, we need to have some of the packages in our application which can be installed via Node, and Node is kind of a required thing in the system. Next one is Xcode for the iOS part development. So Xcode is a tool where user can develop the iOS application. So we must have Xcode to check and run the application as in simulators. And if you want to do any kind of further development, like sometimes we need to have some native development in iOS, then in that case, we also need to have Xcode in our system. React Native CLI tools. React Native CLI tools are the command line tools which we need to have to run the commands of React Native, such as React Native init, React Native run Android. These are some of the commands which we need to run while working with React Native. So we must have React Native CLI tools, which we can install through npm install React Native CLI in our system. Next is create React Native app for boilerplate. So we have a provision in React Native to create a boilerplate by its own. So we can do it by using create React Native app npm. It is not necessary to have, but it is good to have because we are getting a boilerplate through it, and some of the files are already pre-made for you. You just need to add the JavaScript code in that. Next is CocoaPods. So CocoaPods are the package manager for iOS. So if you want to have some of the third-party libraries in your application, then you can have CocoaPods in your system so that you can manage the third-party libraries for iOS, not for Android, but it is not necessary to have, but it is good to have. And to work in React Native, you must have some knowledge of JavaScript and some basic knowledge of React, like how it works and how it goes. So the steps for Android to set up a project is we'll go to the terminal where we want to create the project. We'll run a command React Native init with a project name, whatever name you want to give to your project. After that, we'll go into that. It will create a new directory, and after that, we'll go into that directory which you have created just by using React Native init, and then you will run the command React Native run Android to run the application in Android. So what happens is it will create a bundle of the JS files, and it will start a bundler and the simulator in Android Studio or in the Genymotion, whatever you have chosen as a default simulator. For iOS, we need to go to the terminal where I want to create the project. Then I run the command, same command, React Native init with the project name which I wanted to create. It will create a folder. We'll navigate to the folder, and we'll run the command React Native run iOS. So React Native run iOS, what happens is it will run the application in the iOS simulator. Or what you can do is you can just open the project name.xc workspace file in the Xcode and press the play button on top of the Xcode. So from there you can run your project in a iOS simulator. So I am going to show a live demo. So I hope you guys are able to see my screen. So this is the application which I have created. On the left hand side, we have a simulator for Android, and on the right hand side, I have a simulator for iOS. So we can load the application in Android by clicking Command R twice. So the application get reloaded, and this is like the application is getting reloaded. And in iOS, we can press Command R to get the JavaScript bundle rebuild whenever we make any changes to our application. So let's go to some of the code. So this is the folder which is getting created when I run React Native init. I have created the folder with the name lightning_talk. So these are the folders which get created automatically when we run the command React Native init with our project name. So we have Android folder where all the Android related files are there, and we have an iOS folder where all the iOS related files are there. And I have created the SRC folder. This is where all the JavaScript related code is going to be have. And by default, what happens is we have already app.js where we can start our application. This is the building block our application, where from where the application gets started. So I've just created a text over there, and the text is women who code Boulder and Denver. So this is the starting point of our application. If we want to add any kind of native code, then we can do that in Android folder. And if I wanted to do any kind of iOS thing, I can do it in the iOS folder. Coming back to the slides, I'll talk about some of the pros of working with React Native. It is very faster to build, as we can see that we have same code for iOS and Android. So the development phase time reduces a lot, because we are developing for Android and iOS for this with the same code. Again, multiple platform with single code base, because we are using same code base to multiple platforms. It is easy to maintain and easy to create. Next one is fast refreshing. Fast refreshing is a feature that if you made any JavaScript changes in your code, then you do not have to reload the application and again and again. It get automatically refreshed if I made any change. And the last one is it has very small and easy learning path, and the large community. We have a very large community which is contributing to React Native. So that is a good point. If we got stuck somewhere, then we have a lot of options to ask the problem from. And some of the cons are difficult to create very hard animations. So as we know that from React Native, the JavaScript code is ultimately going to convert into the native Android and iOS code. So sometimes animations may stuck somewhere, and it is difficult to create some animations, like very heavy animations are very difficult to create. Lack of custom modules. So sometimes what happens is we need to integrate some custom modules to integrate some of the features in our application. Suppose we are making a slider bar in our application, and we do not have it is provided in React Native, so we need to go to a third-party library to get integrated. So sometimes what happens is we do not get the desired module which we can use in Android as well as in iOS. So we have to write some native code. So it is good to have some native knowledge of Android and iOS. So in that case, if you got stuck somewhere because of the lack of custom modules, then you have to write some of the native development for that. So these are some of the important links from where you can refer the documentation, and there is a complete guide on the environment setup, which is provided in the React Native documents itself. So that is very good. I personally use React Native documentation for all these things. Yeah, and these are my LinkedIn profile and my website, so you can reach out to me on these. I think this is it from my end.
Awesome. Thank you so much, Rashi. We did have some questions pop up, so I'm going to go ahead and ask you those. First one,
Sure.
any favorite resources for learning React Native?
You can take some of the Udemy courses, but I would prefer to go with the actual documentation of React Native. It is very informative and every topic is well explained. So I personally use the React Native documentation to work with.
Great, thank you. How much actual Swift and Kotlin do you actually have to know to code with React Native?
Not much. For the initial phases, you can just start with React Native, but eventually when the application grows, when you get comfortable with React Native, you should also have the knowledge to how to integrate a native module, so that in future projects, if you get the chance to work on some of the modules, then you should be able to do that.
Great, sounds good. Do you know of any real world apps built with just React Native?
I think yes, the Walmart uses React Native. Netflix is using React Native for their application. So yeah, it is quite. Facebook is using React Native. In fact, Facebook has created React Native. So it is quite well known framework to work with for mobile applications.
Great. And lastly, what's your favorite app that you've built or worked on with React Native?
There is a project called Young Planet. I have worked in my career. So it is kind of a environment saving application where we can exchange the things for free for like the person who does not have the access to any kind of thing. So user can ask other person if they have that, and they can exchange the things for free. So it is a kind of helpful application which I worked on.
Awesome. That's very cool and such a great app for a good cause. So thank you again for your presentation. It was absolutely lovely and for answering all of our questions. We're going to move on to the next presenter, which is Claudia.
Hello. Let me go ahead and share my screen with everybody. Okay. And a little bit of technical difficulties. I can't seem to find it on my screen. Give me 1 second. There we go. Okay. Everybody can see this? All right, thanks. Okay, so today I'm going to be talking a little bit about the differences in creating a UI with UIKit and SwiftUI. A little bit about me. I recently graduated from Lambda School. I really wanted to learn as much as I could about iOS development, and it seemed like the best way to do it is just to immerse myself. So that's what I did. Before I started learning iOS development, I worked for a local community college teaching
Claudia?
STEM. Yes?
Can I stop you? I think we can only see your desktop. I think you might have to reshare the either the Chrome browser or wherever you're sharing your presentation. Oh, now we can see it. Awesome.
Okay. Yeah, so I was teaching community college, teaching STEM to kindergartners to 12th graders. Also worked for a little bit as an airline pilot, going around the United States, Canada, and Mexico. But I really think that my passion is in software engineering, as I always seem to kind of come back to it. So yeah. Okay, so there's pros and cons to SwiftUI, UIKit, and I'm going to show you a demo of me building it in both SwiftUI and UIKit. Basically what I was doing is I was building a really simple interface for a tip calculators. I'm not here to tell you which one I learned if you haven't learned either one of them. I'm kind of just going to show you and then talk about some of the pros and cons of both. So my interface consisted of a text field where the user can enter the amount of their build, and then the user is able to select the tip percentage, 15%, 18%, 20. They're going to have a switch to toggle between light and dark mode, and finally just a button. So pretty simple layout. Here's kind of what I wanted it to look like. Header with the name of the application, a switch to toggle between light and dark, and then the ability to enter the bill amount, select the tip with the selector, and then another card where the calculations are performed, and finally a button down at the bottom of the screen. So when building this out, I was like to kind of just show myself what it is that I'm building and where it goes. So a couple different things that I wanted to implement in both the UI kit and the SwiftUI is labels, views, a switch, a text field, segmented control, and a button. Okay, so it took me, I'm gonna just kind of play this as I continue talking, but it took me 18 minutes and 46 seconds to build the UI with UIKit. It doesn't seem like, I don't know, it depends. I mean, for me, I have been playing around with UIKit for about a little over a year now. So I was really comfortable knowing where everything is and how to make the changes in UIKit. Some issues that I had with it, of course, are every time you make a change and you actually want to see it, you have to run the simulator to be able to interact with it. So that added some time to it. The other thing is you have to change things individually. You can't group them, copy and paste the code. You can copy and paste the elements, but in my experience, they don't ever really end up working or looking what you want them to when you copy and paste. So everything had to be added individually. I wish I could code and work this fast. So after I created the video and I saw that it was 18 minutes, it's like, okay, I'm gonna have to speed this up quite a bit. So had to render this video at 550% speed. And I'm not gonna show you the whole thing, but you can kind of see how it's very, very time consuming. Okay, now with SwiftUI, it took me 11 minutes and 59 seconds to code the UI, just the coding part of it. I didn't count the time that I had to stop and look up how to do something in SwiftUI. Since SwiftUI is new, there's not as many resources that show you how to do things. The one that kept popping up every time I was looking around was Paul Hudson, of course, and his website has a lot more resources than even the Apple documents do. So I think it's probably going on its second year. So resources on the web are starting to pop up a lot more now, but there's still not a lot of help. So a lot of it is trial and error. The one thing that I did find with SwiftUI compared to UIKit is that once you make, like in my case, a card, and you have all the elements and you have it coded out with the colors and the fonts and all that, you can just copy that chunk of code and paste it and then just make little changes, which reduces the amount of time that you're going to be spending creating the UI. Now, the only thing I was doing on these videos is creating the interface, not any of the code, which if we're talking about the code, then UIKit is easier than SwiftUI because UIKit has been around for longer. There's a lot more help on the web. Apple's documents are a lot more clearer and better to understand. And plus the features that UIKit has for the logic is, in my opinion, a lot better than what SwiftUI has. So okay. So some of the pros and cons that I personally found and are an issue for me is UIKit. I'm familiar with it. I know where everything is. I don't have to be looking at videos or tutorials to know how to do things because I've been working with it for so long. So that's definitely a pro. The other one is if you have an application you created in the past, about 2-3 releases from now, it's still compatible. It's not going to break. Cons, the big one is I have to run the simulator whenever I want to actually see changes that I did. And when you connect code to your elements, if you do it wrong or if you delete it, but you deleted it incorrectly, it's going to crash. The error that you get is not very user-friendly. SwiftUI, the pros is being able to see the changes in the preview screen. After you play around with SwiftUI, you kind of get spoiled and you expect that all the time. And unfortunately, it's not there. It's very easy to learn. It's simple. It's intuitive. If you come from a web development where you've used React Native, it's the same declarative style of coding. So it's easier to pick up. It's easier to pick up if you're a designer. UIKit is not as easy if you're coming from a web background. It takes a little bit more time. The cons, as I was creating that video, Xcode crashed on me twice. So I had to close down Xcode and restart it. So it's not as stable as UIKit. And like I was saying, other than hacking with Swift, there's not very many resources for help. So it ends up being a lot of trial and error. And those are my findings on SwiftUI and UIKit. And if you have any questions, I'll take them.
Awesome. Thank you, Claudia. And thank you for that comparison between the two tools. We do have a question for you. So UIKit seemed like primarily visual design tools. How well does that then translate to code implementation of the UI?
So with UIKit, yes, it is a lot, like you said, it's just a storyboard and you add elements. You do have to then create what's called IB outlets to be able to manipulate them and IB actions to perform actions like with the buttons or the switch and the segmented control.
Great, thank you. And thank you so much once again for your presentation. We really appreciated it. All right, our next speaker is going to be Sierra. Sierra, please take it away.
Okay, let's see this screen and take you guys off of this screen. Okay, so we just heard about UIKit and now we're going to talk about MLKit. So let's get started. What is it? MLKit is a package from Google that brings machine learning to mobile apps. What does it have going for it? First, it's optimized for mobile, so you can do processing on your device and completely offline and use inputs directly from your camera. It's also built by Google. The by Google part matters a lot less to me. Most importantly, it's built. And so it allows for hobbyists like me to get involved, to start doing machine learning inside my code. And finally, it's easy to use. And you can tell me at the end of this presentation whether that is in fact true or not. So what can MLKit do? MLKit is broken up into two types of APIs. First, we have the set of vision APIs, and second, we have the set of natural language APIs. So vision APIs can do things like barcode scanning if you want to build a grocery store app, can do things like selfie segmentation if you want to build your own Snapchat. It can do things like text recognition to pull text off things if you wanted to build a credit card reader. And today we're going to be using image labeling, which can label objects in your images. The natural language APIs can do things like language ID. So you can take your camera over a language and it'll tell you what kind of language that is. It can do entity extraction. So if you have a messaging app and you are sending dates or places back and forth, it can extract those places and put them on a map for you. It can do smart reply, and it can do on-device translations. So who can use it? Everyone can use it. MLKit is available for both Android and iOS, so you can easily pull it into either platform. Today, we're going to be focusing on Android because I am an Android engineer, but know that you have the option to go down on either platform. So let's meet our client for the next 10 minutes. This is our client, Steve. Steve also happens to be my father. He really likes playing out in the yard, and he plants a lot of things and can't always remember what he's planting. He finally understands what I'm doing for work, and he asked us if we could help him build an app to solve his problem. And he has a tractor. So with MLKit and image labeling, the answer is yes, we absolutely can. And so today we're going to build a simple app using the image labeling vision API to help Steve identify his plants in real time. So let's get started. So how do we start? Like almost every library in an Android, you have to pull in the dependency using your Gradle. There are two different implementations that you can use. The first packages your model with your application, and the second one dynamically downloads the model from the Google Play services. Since I'm building this for Steve, and I don't exactly trust Steve with his technology, and he's going to be out in the yard away from Wi-Fi, and my parents are notoriously frugal and won't pay for unlimited data, I'm going to go ahead and package it with the app so that it's already there and available for him. We're going to start off using just the base model. The base model has about 460 words built into it already. All right, so step one, we need to prepare our image. Steve takes and sends a lot of pictures to our family group chat, and he screenshots everything you send to him. And so I know he has a lot of pictures to work with already on his phone. So today we're just going to build a simple app that lets Steve pick a picture from his image library and then analyze it and display those results in the application. So the first thing that we need to do is let Steve choose that photo, and we can get started. And we can do that by starting an activity for result and letting Android know that we need to pick that image. And so we do our start activity for result here with the action get content and request choosing an image. And so when that image comes back and our on activity result gets called and is successful, we can pull that image URI out of the data that it sends back to us. Then we need to take that and transform that image URL and transform it into a bitmap. Why do we need a bitmap? This is one of several different types that MLKit can use to generate the image input, but it's also the one that most Android developers already know. In addition, it also turns out to have the best performance with MLKit. And so we take back our image URI, and then using the content resolver, we can transform that URI into a bitmap. And then we'll, just for good measure, so that Steve can see what kind of image he chose inside our application, we'll set that preview inside the app. Now we can go ahead and jump into the actual MLKit. We have our image bitmap, and so we need to transform that into the input image that the MLKit will need. And so here we call our input image.from bitmap and pass in our image bitmap. And then the second parameter is the rotation that we need. And so in this case, we're just going to leave it at 0 because we don't need to rotate our image. This input image from bitmap can be replaced with some of the other functions that input image can also transform, like directly from the content URI if we want it to use something else. Then we need to create our labeler. In this case, we're just going to use the default options. And so we see our image labeling, get our client, and then you pass in the options that you want. Some of the options that you can include are a confidence threshold. So I only want things above a 90%, or a maximum number of labels for it to send back. Now that we have our labeler and our input image, we can actually process that. And so we call labeler.process and pass in the image that we want processed. Process is going to return a task that will be completed in the future, although it is not our friend async task that was recently deprecated by Android, but a very similar concept of a task that will complete asynchronously. To listen for those results, we add our onSuccess listener and our onFailure listener. So that onSuccess will get called when our processor works and the task returns, and our onFailure will call when it doesn't work. So now that we have our image input, our labeler, and we've processed it, we need to handle that return type. Process is going to return to us a list of image labels, and then we can do whatever we want with it. In this simple app, all we're going to do is display those in a list. And so we're going to use our friend the recycler view to dynamically display those. And so we take our list of labels, we pass them into the label adapter, and we change our recycler visibility so that we can see it. Each image label that we get back comes back with 3 different attributes. First, it comes back with a text, and so that text will match one of those 400 different labels that can be associated with our images. It also comes back with a confidence, so how confident the image processing library is that that image does exist in our image. And finally, an index, and that index and text are going to be one-to-one from that base model that we're using. So if we get the first word back, we'll get the first text and a 1. In our simple example app, since all we're doing is displaying those in rows, we just bind those attributes to our row view and we're good to go. So now we have an app. Let's try it out. So the first thing I'm going to do is go in and select an image from my image library. And I already have one saved that's really great of his backyard. And then we process our images. We see it in our recycler view, and they include the index that we get back, the confidence on a scale from 0 to 1, and the index of that text. Steve would be super excited that Google thinks that in his backyard, he has both a forest and a jungle. So where do we go from here? In this 10 minutes, we built a working app that can correctly label his backyard as a jungle. So here are some steps I might take to make this more useful for him. First, that wasn't super useful for identifying anything super specific in his backyard, although it did get the general idea. So we might want to make a custom data model that we can build with TensorFlow Lite and use that model instead of the default. Second, we don't really know where anything is in the image, and so we might want to, oh, I got mine backwards. So I don't save a lot of the photos, but Steve does. So we might want to actually use the camera and use some of that extra processing power that we have from MLKit to just wave around our camera with our camera open and identify the images in real time. Because it could be really annoying to have to take a picture, open the app, load the photo, process, and keep going over and over and over. Next, we might want to overlay the images with the labels so that we know what we're identifying inside the image. In the Google sample app for MLKit, this is actually done for you if you want to check it out. Since I am personally really excited about Jetpack Compose, I might want to rewrite this app in Jetpack Compose to kind of move towards that SwiftUI of the Android side. And finally, probably the hardest, I have to convince my dad to use an Android phone so he can actually use my new app. And so with that, my final reminder is whenever we're using machine learning models, we have to remember that with great power comes great responsibility. And so we are not building these machine learning models, and so you should always be mindful of the bias that might be baked into them and the impact that might have on your users. And that is the end of my talk. All of this code is available on my GitHub. I have a repo pinned of some sample apps I have for different talks and demos, and you'll find this in here if you want to check it out. And if you want to find me, you can find me on Twitter at _Sierra Obryan, or a whole host of contact information is available at sierraobryan.com.
Thank you so much, Sierra. This was such a wonderful presentation, and I love that you get your family members in on it to proof your work, because that's probably the most important part. It's a whole family endeavor. So we have a couple of questions for you. First one being, how much space does the model take up when shipped with the app? Very cool that it runs offline.
I don't know how much space it takes up, but it will take up less space if you do not ship with it. But I don't have a specific number.
All right, thank you. I know that there was some questions about your GitHub, and so thank you for posting that. And as a reminder, all of the presentations will be shared with all of you, so you'll have all of that information in your emails soon. We have one other question for you. Are there any API calls being made for the image recognition, or is it all happening with just the code on the app?
Can you repeat that?
Are there any API calls being made for the image recognition, or is it all happening with just the code on the app?
Just the code on the app. I pulled in the specific library for image recognition, for image labeling. Each one of those APIs has a different library that you have to pull in, so that's the only one that I could work with in this app. And so the process that process call only does image labeling.
Awesome. Thank you so much for that presentation again, and for answering all of our questions. We really appreciate you being here tonight. And last but not least, we're down to our final presenter. We've got Usha. Go ahead and take it away.
Yeah, hello everyone. Just give me a second while I share my screen. Hello everyone. My name is Usha. I am an engineer and financial products org at Uber. Before Uber, I was a startup founder and tried my hands on building different apps and my own company. And afterwards, I joined Uber. I'm going to be talking about mobile analytics and how do we use analytics at Uber. This is a quote that I love from Peter Drucker. If you can't measure it, you can't improve it. So this aptly useful for analytics. So what is mobile analytics and why do we need it? So if you are an individual developer launching your apps in App Store, or a company like Uber with millions of customers, you need a way to measure your user behavior, right? You launch your app or launch a new feature, then you need to know like how your users are interacting with it. Is there going to be like any crashes, or people are just dropping off, they're not using that feature. So otherwise we are flying blind. So collecting this data helps us to just go back and ensures that there's a feedback loop. You're going back and fixing and making sure you are, listening to your users. It's a way that you're listening to your users. So how do we use analytics in Uber? So the basic way is all this mobile analytics we use to understand the user behavior and improve the user experience. And also any customer issues, if you're facing, proactively it will help us to debug this. So we don't have to wait until we hear from our customers. So another important thing is powering intelligent features. So what do I mean by that is, so let's say if you are ordering from Amazon, you're doing it in the comfort of your home and you're just browsing your products and taking your own time, and you can order it. But with Uber, if you are like requesting a ride, you are probably stuck somewhere, standing in a street corner, or you just landed in the airport and in a hurry to get back home. So we don't have that luxury of, waiting. Our user experience needs to be very smooth. So all this data from driver and traffic conditions, all this help us to predict ETA. So, like 3 minutes, I'm getting my Uber, or in 5 minutes, I'm getting Uber. So this helps us to do all these predictions. And most importantly, we also use data in very anonymized and aggregate form. So we only care about like how many users are using or entering this flow, how many of them are dropping off, rather than tracking the individual user and using PII data, etc. So what are the different types of metrics we use? One is like business metrics. It's mainly to know like how many rides are in a region, or how many deliveries that we make. Those kinds of data that will help to make business decisions. Whereas there are more system metrics or reliability metrics that is for either for your backend services or for your mobile. Let's say you have a feature and you're tapping on the button. So how fast you're getting the response back. That is the latency that you're measuring, which is very important. So you don't want to, your users to be waiting there in a feature, and its reliability is equally important even for your backend services as well. So the other one is that, which I already mentioned, is the user experience metrics, which is like, so you have a feature like either you are requesting the ride or ordering the food on Uber Eats. So how many users are entering that flow? Are you able to successfully complete your order, or you're dropping off, or you're getting some failures? So those are the things which which we are measuring. So imagine like for a small app, like we'll be measuring all this data, we are going to get tons of data. Imagine at the scale of Uber. Uber operates in some 65 countries with 7 billion trips annually. That's a lot of data. So you're getting all these user interactions, and how do we process this data in Uber platforms? So most of our analytics platform, so we don't use any off-the-shelf products. Our analytics platform is homegrown. This is like very, very high level. I'm not covering all the components that we have used. So very like 30,000 foot viewers. Like we have like multiple apps. So like there is rider app, driver app, eats app. Each of these apps, there is an analytics library that we use. So which gets all the user interactions, events are collected, and it is sent across. And all these raw events, they themselves, they don't make much sense, right? So ideally, you should be able to slice and dice your data. You want to know like how many of iOS users are using it, or how many of Android users. And we usually will have like multiple versions of app running at any time. And we would want to know like if there is a problem, it is happening in this particular version. So that is where mapping service helps. So for events, we normally define rules. Like for these events, I want to measure along these dimensions, along like app or app versions, a city, whatever it may be. So we define these dimensions. So then these rules are applied onto these events, and they are published to Kafka topic. So, and then these events get ingested by Hive and Elk. Hive is like a data warehouse, like all our data is stored there, which is like be used by either data analyst or somebody to query and analyze data. And we also like to generate any reports, those kind of information. This is like very high level. So I just want to walk through one funnel that our team FinProd uses. So if you have seen in Uber app, we have Uber Cache. So Uber Cache is nothing but a balance that you are storing in Uber, that you can use it in Uber ecosystem for anything. So delivery, eats, or a ride, anything you can use it. So it's a very simple funnel here. When user clicks on add funds, they get to see all these options. And these options, they vary depending on what region you're in. So some regions, the gift card is not available. Some regions, we don't allow auto reload. So these options that you see may vary. So once these options come up, there could be some optional steps, like if you want to change your credit card or something, there may be extra steps, but this is like a simplistically, this is a funnel. You take this simple funnel, once you click add and you get a success. So if you take this simple funnel, each of this is one step. So what we are measuring here is for one step, that is that the one that where I showed like what options you're getting. This is a kind of data that we measure, like how many sessions are there and what is the conversion rate. Conversion rate is usually from one step, how many users are moving on to the next step. And also shows us like what is the latency and what is the failure rate. So this data helps us to proactively, we keep looking at it. And if we see like higher rate of failures or high latency, it helps us to investigate immediately. Okay, so this is no means like we are covering like entire Uber analytics platform. It's like from high level, this is what we do. Okay. Just a couple of resources, like there is Uber engineering blog, there are like very interesting articles of different teams that are working on, great read, and also let plug in for Uber careers. Thank you.
Awesome, Usha. Thank you so much for telling us a little bit more about a very, just a sliver of all the mobile things that happens on the app. So we appreciate your talk on that. All right. With that, it looks like actually we're a little bit ahead of schedule. Just want to open up the floor one more time. Does anyone have any other lingering questions, comments, thoughts? And it looks like Grace just posted the link to join the Women Who Code Slack specific to this mobile event. So if you want to kind of continue the conversation in there, please feel free to join us in there as well. Otherwise, I'm going to sign off soon. Grace, Jen, anyone from Women Who Code, did you have anything else to add?
Nope, this was really awesome. So thank you so much to all of our speakers. We love events like this. I learned a ton, so thank you.
Awesome. Thank you once again, everyone who came. And just going to do another plug. We are in desperate need of a bunch of mobile devs. So if you were on the call, please feel free to apply, especially in the Boulder office. We'd love to have every single one of you. If I could get an office of like 50 female mobile devs, that would be my dream. So yeah, you know where to find us. Thanks again, everyone, and have a great night.
Thank you, everyone.
Thanks, everyone.